during refraction. Number one, direction changes. Direction changes. That's number one. During refraction, wavelength changes. Wavelength changes. Yeah, to allow people to sit down. Apart from the first row, others adjust your seat. If you don't adjust, no university until 2030. So adjust it very well. Adjust it very well, very well, very well. So that people can sit down. If you don't adjust, no school until 2030. So do it. Adjust it. Don't say because you are in front of the screen. Move it. Velocity changes. And there's one major one here. Frequency remains constant. So during refraction, frequency is constant. No change. For frequency, constant. Our N is velocity of light in air, VA over VG. Refractive index. We can also have N is VA over lambda G. Lambda A, velocity in air over velocity in the medium. Can also be water. Or N is VA, depending on the medium, over VW, water. Can have N is VA, lambda A. So you can use wavelength as well, over lambda W. So you can use refractive index to be velocity in air or vacuum, over velocity in the other medium. We also have Snell's law. Snell's law, N is sine I, all over sine R. We also have N1 sine theta 1 is N2 sine theta 2. N1 sine theta 1 is N2 sine theta 2. There's a law we call the Brewster law. I don't know whether you have heard of that before. Brewster's law. N equals tan I. When the angle between the reflected, when the angle between the reflected ray and refracted ray equals 90. Reflected ray and refracted ray, when the angle between them is 90 degrees. So we have the Brewster law. N is tan I. Tan I, Brewster law. Of course, we also know that N for liquid is real depth over apparent depth. All these are what you know. This is an interesting part of physics. Real depth over apparent depth. That's N, refractive index. And then our displacement, sometimes they ask you to find lateral displacement. That's real depth minus apparent depth. Displacement, real depth. I don't want us to start writing formula. D is T into 1 bracket, 1 minus 1 over N. It works. So we talk about critical angle. Critical angle, what is critical angle? Angle of incidence when angle of refraction equals 90 degrees in the less dense medium is I. So critical angle is the angle of incidence when angle of refraction equals 90 in the less dense medium. In the less dense medium. Then we know that C is arc sine 1 over N. And N also is 1 over sine C. So all these are what happened during critical angle. For total internal reflection to occur, we all know what happened. Number one, I must be greater than the critical angle. Number two, light must travel from where? Denser to less dense, denser to less dense. No story, just synoptic form. The principle of total general reflection is used in the explanation of mirage or mirage or mirage or mirage. Anyone? Uncle Daniel. So we have that. So we have denser to less dense. Then we have I greater than C. Angle of incidence greater than the critical angle. Then thin lenses, the same thing you learned in lens, we also learned in mirror. 1 over U is 1 over V. 1 over U plus 1 over V is 1 over F. And then we know that our U again is F into 1 plus 1 over M. And V is F into 1 plus M. Then 1 over F is 1 over F1 plus 1 over F2. Then 1 over F was N minus 1 into 1 over R1. This is called the lens maker equation. Lens maker. So all the image formation that you have learned in mirror, the same thing in lens. So image formation in concave lens is the same as that of convex mirror, which we have done. This is very important. Class, in convex mirror, what is the nature of image in a convex mirror? Visual first, virtual erect, and that means in concave lens, we also have visual, erect, and diminished. So concave lens and convex mirror are both divergent. They are both divergent, so they have the same thing. So image formation in engineering student, you have not adjusted your shares, so adjust it. Indomie stand and oh yeah, I'm moving forward. Let me hear the sound here. Those of you under the canopy, God bless you. I can hear it now. God bless you. 345. Image formation. Yeah, thank you. In convex lens, don't be far from the screen so that you don't get distracted. Image formation in convex lens is the same as that of concave mirror. Move closer to the screen. Don't stare at the back. Concave mirror. So that's that on topic 25. 14 more to go. I was told about some dirty girl fighting in my school yesterday. Those one, I'll beat hell out of them. For example, for all of you, that all the things you've been taught, the moral teaching, the church teaching, everything is a waste. From my school to boxing ring. People that girls that always fight like that, they are called ashewo. Yes. People that, yes, you go to their brothel in front of you, you'll be hearing noise of ladies. So how can you be fighting a few days to the exam? We're not fighting, we're arguing. I can hear the voice on my phone, the shouting of some of you also. Some of you also, you are also making case worse. You can't be a peacemaker. You're adding petrol to fuel, to fire. I'll beat two of them like as if I'm beating a primary 2 girl. And after that, they will go home. Yes, you go and be doing online. That's not what I need from all of you. Now, what I need from all of you is peace of mind, not the day I should be resting or doing something. I said, your children are fighting. Is that what I want to be hearing from all of you? They should go and do online now. They should fight with their parents at home, not in my school again. We'll carry you to church. We'll do everything. Yet, the only thing you know how to do is to fight and misbehave. Image formation in concave lens. It's the same as that. Now we don't have time for glass prism. For glass prism, we saw point like that before too. Our n is what? Sine what? A plus dm over 2. All about what? Sine A over 2. At minimum deviation, what happened? At minimum deviation, something happened in a prism. What's that? What happened? Light passes symmetrically through the prism. Light passes symmetrically through the prism. Light passes symmetrically through the prism. Through the prism. At minimum deviation, light passes symmetrically through the prism. For those who cannot see that, I wrote at minimum deviation, light passes symmetrically through the prism. At minimum deviation, light passes symmetrically through the prism. So at minimum deviation, A is 2R. A is 2R. So that's the end of that topic. It's quite an interesting topic. It's similar to mirror. I'm planning to move my mock exam to Saturday, this Saturday, so that we can have time to do more revision. What's that? You don't need any day to read anything anymore. Have you not been reading? You have been doing revision, so what's the big deal? If I move it to today, you will write the exam, you'll pass. What's the big deal? Are you going to read extra for mock when jam is next week? What have you been doing? Have you been playing? You've been fighting? Or you have allowed Abiba's spirit and other spirit to catch you? Yeah, those are spirit of fighters. So for my exam, it will likely be this Saturday. I will announce by 12 today. Final verdict. And it won't stop us from having classes. We'll finish more continuing lectures. Are we ready for question now? So the first thing I wrote is that during refraction, when light is coming, it gets to a particular medium, a boundary, then the light, instead of it to go like this, it won't go like that. So the light undergoes deviation. That's the meaning. It depends. The movement towards the normal or away from the normal is a function of the optical densities of the media. If you are traveling from denser to less dense, what does that mean? I mean the light has more velocity, so it's spread out. Pew. So if a light is traveling from a denser medium to a less dense medium, it is refracted away from the normal. That's the meaning of refraction. I'm coming from glass to air. What will happen? When I get here, I will just go like the pew, refracted away from the normal. If I'm going from less dense to denser, I am bound to move towards the normal, like that. That phenomenon, where you have apparent change in direction of light or waves, when it travels from one medium to the other, is called refraction. Refraction. Apparent change in direction of wave when it travels from one medium to another. So, and it's always about apparent. It's not really direct. It's apparent change. And that's the reason why sometimes when you stand in front of a pool, swimming pool, the pool appears to be shallow. And unfortunately, the pool is not shallow, it's deep. The pool appears to be shallow until when you enter it, you are in trouble. I told you last it was this jam class I told you about how I embarrassed myself. I enter a pool and all that, I think it was in the US, yes. Went for holiday that time with my family. My children can swim because they went to school where they were taught swimming. My own school would never enter swimming pool before. From GSS, from primary, any time till the end of my secondary school, I have never touched water inside swimming pool before. For you to know how local the environment I came from. And then I was not exposed that way. So, and we were in the US. And then I look at the pool that people are jumping into. It looked very shallow, very small. People, they will go and enter from here. It's like a, water coaster. Just dive in, pew! And then they will enter pool. Ooh. And when they enter pool, they will now swim out. Wow. So I was thrilled by everybody's movement. My own daughter went, pew, and then came out. My son, come out. As I must do this thing. So many adults, also many people doing it. They said, Daddy, don't do it. So what? You guys were doing it. What it was bad? Daddy, don't do this thing. And the stubbornness of a man will always kill a man one day. And then I went. My heart was jumping like that, beating faster. Then I went. And I remember those things resonating in my head. Daddy, don't do it. It was a pew. That was the last thing I can remember. The last thing I can remember. The pool was extremely deep. So I was, what I was thinking in my mind is that even if it is very deep, I'll just stand and then I'll walk out. But it swallowed me. That my head was inside, my leg was not touching the ground. I was blabbing in water. I cannot breathe anymore. My children were almost, what? We told you. And then they will have to start blowing whistle. Then the rescue team came and then carried me like a baby and pushed me and was shaking. Popping my chest, water color. Oh, God. I just looked like a used toilet roll. I was so ashamed. I said, I'm sorry, children, I'm sorry. I was just trying to experiment something. Extremely deep. I can swim small, but this one I don't feel swim anything. I forgot all the swimming lessons I've learned in my life because it was very deep. So that phenomenon that make a pool to look shallow when it's actually deep is refraction. Sometimes again you get a bowl of water here. You have a bowl of water and then you put a stick and the stick is very straight too. But then you look through from the top, it appears bent. That's another effect of refraction. It appears bent. And how do we explain the concept of mirage? Total internal reflection. We are going, those are the things that are interested in when we're traveling young with our parents. We see something that looks like a pool of water on the street, and we are trying to see that pool of water. Why can't you have river on the road? And we get there, it disappears. Later it reappears, then disappear like that. That's mirage. So all these are concepts of refraction of light. And then we should not forget the fact that three things change, as I've said earlier. Velocity will change, wavelength will change, direction will change, but something will remain constant. And that's what? Frequency. Frequency never changes. At total internal reflection, two things happen. One, the angle of incidence in the denser medium now is greater than the critical angle. Very important. Greater and critical angle. And then light travel from denser to less dense. And then these are the things that we need to know. So just take 10 questions as usual. Topic 25. So you guys are really enjoying physics now. So much power, so much strength you have when it comes to physics. So we go to example. Right, correct. Question 1. The correct shape of the graph. The correct shape of the graph of UV against U plus V. The correct shape of the graph of UV against U plus V for an object distance U and image distance V and image distance V and image distance V and image distance V. Then experiment image distance V, then experiment to find the focal length To find the focal length, of a convex lens is given by, to find the focal length, focal length of a convex lens is given by, look at that. By now you should not be afraid of, they give us 4 diagram, but I'm not interested. We just draw it our own, get the answers on our own, and move on. Okay, so we have 1 over u class plus what? Equals what? What's the sum of u and v? uv. What is u in uv? What is v in uv? Equals what? Cross multiply. Chum chum. Let me just do like this. uv equals f into what? U plus v, or v plus u. That's it. Now, you now say compare with what? Our normal equation of a straight line. That's why we say you stay in math class. Y equals what? Ms plus c. Now, what did they do? They plotted uv against u plus v. Look at this. They plotted uv against what? That's what they plotted. Class, if they plot uv against u plus, that means your y is uv. Am I communicating? Your s is what? U plus v. Class, is there any c here at all? But there's no c here. That means the graph must not have y-intercept. Must that have what? There was one option like this now. They do like this. Pium. They put uv here. Don't put u plus v. You are wrong. So why is it wrong? It's having y-intercept. They do another one like this. Boom, boom. Can't go like the pium. Went this way. You are also wrong. Why? It's having y-intercept. So any graph that looks like that has no y-intercept must pass through the origin. Must pass through what? So the graph will be like this. That's the answer. Then this m represents what? Somebody. That means the slope of this graph give us the word focal length. That's it. So that's it. So sketch this one and then you put something like now write slope equals f. Because you can ask to find slope next time. You can plot the graph and they ask you to find the slope. So use that one to get the slope. Those sitting down at the staircase, enter class or there are spaces. Anywhere you see bag, the fellow that owns the bag is a friend of somebody who is still at Iyanokwaja at this time. So sit down. Now, if you plot another graph, there's another graph again, 1 over u against 1 over v. Have you seen that graph before? How does it look like? Okay, so in case Jam decides to change it and give you another graph, if you plot 1 over u against 1 over v, this is how it goes. 1 over u against 1 over v. To go like the so this is O, this is AB. This is how 1 over u against 1 over v goes. It's constant. And then our f is 1 all over OA or 1 all over OB. It's the same. From here to here and from here to here are the same. Then we plot magnification against V. M against V. Now go like the this place minus 1. Then this one is, this is OA. F is 1 over OA. So 3 graphs can be required for you to know, even for mirror and for lenses. When you plot UV against U plus V, slope na F. You plot 1 over U against 1 over V. Slope is 1 over Y-intercept or 1 over X-intercept. You plot magnification against V. Slope. How do you find your F? F is 1 over OA. This one must pass through -1, compulsory, from this formula that we derive. Is Osage in class now? Okay, praise God. Welcome. Sorry there. Undo. You guys are stressed, I know. So much work, so much reading. Let's go. Number 2. A ray of light passes from air to water. A ray of light passes from air to water to glass. A ray of light passes from air to water to glass to air. Oh God. From air to water to glass to air. Given that the refractive indices, given that the refractive index for light, given that the refractive index for light passing from air to water, given that the refractive index for light passing from air to water is 4 over 3. Is 4 over 3. And air to glass. And air to glass. And air to glass is 3 over 2. And air to glass is 3 over 2. And air to glass is 3 over 2. Full stop. Calculate the refractive index of glass relative to water. Calculate the refractive index of glass relative to water. Of glass relative to water. Of glass relative to water. Okay. Oh, yeah, read the question. Let me hear. Air to water. Look up. Oh. Air to water. Oh, yeah, go on. To glass. To air. Yes. Given that. Look at the board. Air to water. Air to water. 4 over 3. Yes, go on. Air to glass. How much is that? 3 over 2. Yes, go on. Glass relative to water. Correct. Glass relative to water. They didn't say glass to water. Glass. Read the question again. That last line. Calculate what? So the glass has to end relative to water. You know? They didn't say from glass to water. They said glass relative to water. So glass is the major one. Now, WNG. Look at the ball. In vector, look at vector. AB plus BC equals AC. In vector. This one and this one are common. They will disappear. That's what you do in vector. SY class in vector plus YZ. What will it be class? SZ. Very good. Then in vector, AB is the same thing as minus BA in vector. So if I want to find WNG now. See what I will do. Because I have WNG. Look up with WNA times ANG. So what are you trying to synthesize vectorially? Because that when the two p's are together, they will remove themselves and have AC. So WNG is WNA times ANG. So A and A beside each other, what will happen to them? They'll disappear. Now, if A and W is 4/3, WNA, what will it be? 3/4. Just turn it upside down. What's ANG class? 3/2. What is 3 times 3? 4/8. 1 point what? 1.11111. What do you get? 1 point what? 1.125. Copy that. $1.125. $1.125. Relative index of glass relative to water. This glass. You put water in front. Relative index of glass relative to air. Glass. Air. So the one they want to find refractive index rather must be here. Refractive index of water, you put water here. Refractive index of gas, you put G here. Refractive index of glass relative to water, you have glass here, you now put water here. WNG. Ground 3, shall we? Classwork. An object is placed 10 centimeter. An object is placed 10 centimeter. 10 centimeter from a converging lens. From a converging lens. From a converging lens of focal length 15 centimeter. From a converging lens of focal length 15 centimeter. Full stop. Calculate the magnification of the image formed. Calculate the magnification of the image formed. Of the image form. Classwork. Well, you know this question. You shouldn't miss this. Taught you last week. I5 sine 200 pi t. I solve it for you. 0.4x. So this one is a sine 2 pi ft minus 2 pi over lambda x. Now say 2 pi over lambda is 0.4. 0.4 lambda is 2 pi. Lambda is 2 pi over 0.4. In this case, your pi, maybe that's why you didn't get it, is 3.142, not 180 over 0.4. So, that was 6.284, 284 divided by 0.4. So the answer is B, the owner, 15.7. You have to use 3.142. We are not talking about, this is not phase difference that you use pi to be 180. Are we true? What's the answer? Shy. Read the question. 10 centimeter. Yes. Focal length 15 centimeter. See, anything converging in this world, whether it's a lens or a mirror, must have positive. Once you are converging, yeah, go on. Yeah, I want to find M. Now, the common sense must tell you, number one, the image must be visual and then magnified. Why? The object U is between the focus and the optic center. That is the meaning. You can see U is less than F. So once you have that, M must be. If you don't get negative answer, you are wrong. Go. If your answer not big past 1, you are also wrong. So all those small things should be in your mind as you are solving. You want to use your formula that I have been given, no wahala, use it. If you don't like the formula, go and find V and then use M is V over U. So U not 10, you have 15 here. 1 plus 1 over M. 10 over 15. Now be 1 plus 1 over M. What's 10 over 15? 2 over 3. Abi? Equals 1 plus 1 over M. 2 over 3 minus 1 equals 1 over M. What's 2 over 3 minus 1? Minus 1 third equals 1 over M. M is minus 3. That's the answer. But you don't see minus 3 in the exam. What do you see? 3. You now pick 3. Who got 3? Anybody? That's it too. Anything lens, mirror now, you should be getting it. Mr. Adams, I went to find my V first. Why not? 1 over U plus 1 over V is 1 over F. They can now say M is V over U. It will work. Number 3, let's go. The refractive index of a material. The refractive index of a material is 1.5. The refractive index of a material is 1.5. 1.5, full stop. Calculate the critical angle. Calculate the critical angle at the glass-air interface. Calculate the critical angle at the glass-air interface. Critical angle at the glass-air interface. Critical angle at the glass-air interface. Class 4, you know how to do it now. Formula has been given to you. C is arc sine 1 over n. Apply it. Tonya, what do you get? Oh yeah, apply the formula quickly. Oh yeah. What are we looking for? Is it N or C? C, arc sine 1 over n. What John will give you basically is to give you the one that has to do with sword. And they always like to give root 2. Now say arc sine 1 over root 2. Now get 45. So I don't use calculator. So arc sine 1 all over n. What's your n? How much? 1 point. Yeah. So we're going to have arc sine. What's 1 over 1.5? 0.666667. What do you now get? 41.8. Thank you. Next question. Number what now? A diverging lens, number 5. A diverging lens of focal length 30 centimeter. A diverging lens of focal length 30 centimeter produces an image A diverging lens of focal length 30 centimeter produces an image 20 centimeter from the lens. 20 centimeter from the lens. Full stop. Determine the object distance. Determine the object distance. Classwork. Are we true? Some of you are going to miss it. Why? Sign convention. That has been your problem. Read the question. Let me hear. That is the word. Diverging. Anything. Once you see diverging, once you see anything diverging, whether it's lens or mirror, diverging. Number one, anything diverging. Number one, M na negative. V na negative. F na negative. That's it. Anything diverging. Anything diverging. M is negative. V is negative. F is negative. All right, let's go now. A diverging lens, yes. Focal length what? 30. So our F now be minus 30. Can you see that? So what about if it's a diverging mirror? The same thing. Diverging lens. Anything diverging in this world, negative, those three. And they won't tell you. So once you don't put minus, you have missed it. And the answer you will get will be in the option. Oh yeah, read it again. The diverging lens of what? Yes. Image. That's your V. Minus 20. Can you see that? Don't miss out. Determine the words. Can you see? That's it too. So learn it. I beg you, get it now. Anything diverging. These three are negative. The three. So note it now. So 1 over U now plus 1 over V. Now be 1 over F. 1 over minus 20. Plus 1 over V. Will now be minus 30. So your V. Are we looking for U or V? Okay. Now the same thing. So V now is minus 1 over 20. So 1 over U now, minus 1 over 20, minus 1 over 30. So 1 over U will now be, transfer those 1 over 20, minus what? So 1 over U will now give us, what's the SCM? 60, 20 and 60, 30 and 60. So 1 over U will now be what? What's your U now? Mr. Now, when I did my own, I got you to be negative. That means you are wrong. Whether you are a converging, diverging, mirror, lens, object must always be what? Positive. Whether you are so once you are getting U to be negative, you know that there's an error somewhere. Your U, otherwise you're having virtual objects, and we have not gone to that level. Now we have virtual objects. Because anything virtual means it's like not real, apparent, like a ghost. It's only in Nigerian movie that a ghost want to cross road. He's looking at a road like this before he cross. Now ghost too. It's only in Nigerian movie somebody will put poison inside food and it will test it. to know whether the poison is going to be rich or not, and he will not die. So a ghost does not need to knock the door before it comes in. So your you can never be negative. Number 6. Refraction of light differs. Refraction of light differs. Refraction of light differs from reflection. Refraction of light differs from reflection in that some of you are the far back. If you don't want to see, come and sit here. I hope it's not that fighter that is holding seat that you are reserving seat for. Come and sit. There are spaces. Some of you are the far back. Refraction of light differs. If you don't want to see, come and sit here. There is one seat at the front here. Refraction of light differs from reflection in that, in refraction, Romans 1, at least 2 media are involved. Romans 1, at least 2 media are involved. At least 2 media are involved. You're not writing, be writing. At least 2 media are involved. At least 2 media are involved. Romans 2. There's a change in the direction of the ray. There's a change in the direction of the ray. There's a change in the direction of the ray. There's a change in the direction of the ray. Romans 3. The speed of the ray changes. The speed of the ray changes. The speed of the ray changes. Right. Which of the above is or are correct? Which of the above is or are correct? Uncle Daniel Como. Which of the above is or are correct? Option A. One only. Option A. One only. Yeah. There are seats here if you are just looking for seats. One only. Option B. 1 and 2 only. 1 and 2 only. 1 and 2 only. Option C. 2 and 3 only. 2 and 3 only. 2 and 3 only. Option D. 1 and 3 only. Yeah, pick one answer. 1 and 3 only. Pick one answer. Okay. The which of the following is the difference between refraction and reflection? What's the number one? At least two media are involved. Is that correct? Read the question, everything. In refraction, yes. Is that correct? Talk now. Is number one correct? You need two media at least. You can have three, like one we have today. From air to water to glass to air. That's three media. Going back to air, I don't want to call air making the fourth, but at least two media involved. What's number two? Is that correct? Is that correct? So during reflection, there is no change in direction. Look at reflection. When a ray is coming like this in reflection, bam, reflection of light. When the ray is going like this, you see its direction. No? So when it gets here, it will continue and be ray of light. During reflection, does it continue like that? So what happened to the ray of light? This reflected ray. There's a change in direction for the two of them. Come like this. Pew. So there is change. So I know you're going to miss it. All of you will say, yes. In refraction, three things will change. Direction, and I know you are going to miss it. So there is change in direction. What's number three? So two is wrong. What's number three? Is that correct? Yeah. So the answer is what? Is 1 and 3 there? Very good. So please read. Many of you are good at calculation now, but all those story you have to get them. Get them. And if you are smart, if you go to Lamlad has so many stories, true or false, question like that. You can still spend time but many of you are very solid when it comes to calculation. There was a jam question some years ago in one of the CPT exam. Out of 40 questions, calculation there about 7. So we want to have a story 33. So then, I didn't like story. I like calculation. Then you are going to be in trouble. So balance up. Question number what now? Number 7. A coin placed below a rectangular glass. A coin placed below a rectangular glass block. A coin placed below a rectangular glass block of thickness 9 centimeters. A coin placed below a rectangular glass block of thickness 9 centimeters and refractive index 1.5. And refractive index 1.5 is viewed vertically above the block. 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 Full stop. Find the apparent displacement of the coin. Find the apparent displacement of the coin. Find the apparent displacement of the coin. Apparent displacement of the coin. Classwork. Are we true? So refractive index is real depth over apparent depth. That refractive index, real depth over apparent depth. What's the refractive index they gave us? 1.5. What's the real depth? Apparent depth, x, 1.5x is 9. Is your S6? If you pick 6 as answer, I hope you know you are wrong. That will be option A. Oh, don't pick it. I beg you. People have been falling into this trap every year. They want us to find displacement. Displacement is real depth minus what? There's a formula directly for all of them, but I don't like it. It's not bad though. 3. Our displacement is R into 1 minus 1 over n to work. Question 7. 8. An object is placed. Question 8. An object is placed 15 centimeters from a diverging lens. An object is placed 15 centimeters from a diverging lens. 15 centimeters from a diverging lens. Of focal length 12 centimeters. 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 Full stop. Find the image distance. Find the image distance and its nature. Find the image distance and its nature. That's what, please, I beg you to get this one. Get it. I don't want to hear I made mistake. Oh, get it. Are you true? Oh yeah. Read the question. Let me hear. Diverging. That's the word. Those some people have missed again. They don't go see them. Anything diverging, I've told you. F na negative. V na negative. M na negative. The three of them. Oh yeah, read it again from the beginning. That's our U15. That one no concern on our U is always for yes. Focal length what? 12. Minus 12. Oh. So that's it. 1 over U plus 1 over V. 1 over F. 1 over 15 plus 1 over V. 1 over minus 12. Please don't tell me I've forgotten again. Those three. And the only way of remembering that is to solve many questions. Practice before exam. SM na 60. 12-year, 5-year, 1 over V minus 9 over 60. V will now be what? Minus 60 over 9, Abby. So what's that? Minus 6 points. The image, what's the nature of the image? Virtual, Abby. It's virtual. So how do you know it's virtual? Because of the negative. And the answer is 6.67. Anything that virgin can never give you magnified image in this world. Never. So it's virtual. Come on, manager. It's virtual. So it's virtual. Next question. Number. A swimming pool is 2.1 meter deep. A swimming pool is 2.1 meter deep. A swimming pool is 2.1 meter deep. Full stop. If it contains water, of refractive index 1.3, if it contains water of refractive index 1.3, come on, calculate the apparent depth of the pool. Calculate the apparent depth of the pool. Last work. That is Sola, what do you get? Eh? Class, refractive index is read depth over what? Are you given read depth or apparent depth? What's this one? 1.3. What's real depth? Apparent depth unknown. 1.3x is 2.1. So S is 2.1 over 1.3. What do you get? 1.6. 1.62. Last question, 10. A converging lens of focal length 10 cm. A converging lens of focal length 10 cm. A converging lens of focal length 10 cm. Converging lens of focal length 10 cm forms an erect image. Forms an erect image. Forms an erect image 3 times the size of the real object. Forms an erect image 3 times the size of a real object. Full stop. Calculate the distance between the object and the image. Calculate the distance between the object and the image. Class work. This time between the objects and the image. Are we true? Some of you will miss the question, no? Because you don't read line by line. Oh yeah. Read the question. Converging lens, yes. Because it is converging at plus 10. Yes, go on. Erect image. Once you are erect, you are what class? Virtual low. So you don't know. Erect image 3 times, Abi. So minus 3. Why is an erect? When you say erect, I've told you, erect is virtual. Erect is virtual. Oh yeah, go on. 3 times, yes. They didn't say find you. Some of you find you, you stop. Between the object and the image. Not between the object and the lens. Use F into 1 plus 1 over M. What's your F? 1 plus 1 over minus 3. That'll be 10 into 1 minus 1/3. That'll be 10 times 2 third. That'll be 20 over 3. Abi? 6.67. That's never the final answer. That will be option A for many of you. You go and find V. F into 1 plus M. What's your F? 10. 1 plus minus 3. That'll be 10 times 1 minus 3. 10 times what? What's that? Now, in a lens, let's use a lens, converging lens. Our F now 10. F 10. I don't want to show you something. F now 10. Don't wonder the object is virtual. That's it. Erect. So that means our U was 6.67, somewhere here. This object distance, 6.67. And you have been taught that when the object is between the focus and the optic center, just like the mirror, you're going to have virtual image. So it is here. It was placed between this place and this. And I told you, firm, virtual, erect. Go and read the note I gave you. I said, all the things that happen in concave mirror, they also happen in convex lens. So all those rim, read, wrist, I would do for concave mirror, they are the same thing for convex lens. Mr. Adams, what happens in a converging lens when an object is placed at the center of curvature? Real, inverted, same size, wrist that I gave you. What happens in a converging lens? Converging lens means concave mirror type. What happens in a converging lens or convex lens when the object is placed beyond the center of curvature? I give you read. The answer is real, inverted, and what? Diminished. So what happened when an object is placed between the principal focus and the radius of center of curvature in a convex lens? The same thing with the mirror, the same thing with the concave mirror. Real, inverted, and magnified. Then your note too. You know. So see your virtual limit minus 20. That means how many will be here? Because it's erect. If it is real, it will form this side. If it is virtual, the same side. So from here to here now, how much class? I can't hear you. This is 20 now. The answer, find the distance between this and this. So our answer will be 20 minus. We're going to start cramming rubbish. 20 minus 6.67. So the answer is 13.33333. If you get this one, that means you are solid. Or a solid student. Oh, Pano has taught you all these things, though. So I don't know what I did. I just added the two of them. Minus 20 plus this one. That's okay. So if there is no minus here, then you add this also. You still get 26.67. So if you add the two, you will get this one. Do a minus there. You now throw away the minus. So if they have to find distance between the object and the lens, you can try to add the two. You can add the two. So how many have we done now? Thank God. So I go to topic 26. Is optical instrument, the next topic. It's a simple topic, it's not much. It's almost 9, so Mr. Shoemi will soon come in. So, optical instruments. Number one, simple microscope. Only one lens, one convex lens. Final image is visual, erect, and magnified. That's all about that. Number 2, compound microscope. VEM means visual, erect, magnified. Compound microscope. 2 convex lenses. 2 convex lenses of short focal length. Short focal length. So now we call them MUSIs. Or we also call them MUSEL. The word MUSIS means both of them are short shots. Objective short, eyepiece short. But when you have MUSEL, it means the objective is shorter, eyepiece longer, small. Not too long, but at least. Then final image. This one is very strange. Final image is visual. But unfortunately, this time around, because it's inverted now, very strange, and it's magnified. But there are 2 lenses, that's why it is like this. So it's different from what we have been used to. Number 3, we have telescopes. Astronomical telescope. So 2 of them are, when they combine 2 lenses, they produce strange results. That is one now. So we have 2 convex lenses also. 2 lenses. For the first time in the history, we have this because there are 2 lenses. The first one is real, inverted, magnified. But now this one is not only virtual, but inverted. But compared to the first one, it is erect. I will explain. 2 convex lenses. We call it tool. And it was discovered by a man called Galileo Galilei, Italian astronomer. Tools, objective longer than the eyepiece. Then we have terrestrial telescope. The final image also here is VIM. At normal adjustment, final image is at infinity. At normal adjustment, they like to ask for that. Final image is at infinity. But apart from that, you still have terrestrial telescope. Terrestrial, is it double R or single R? I've forgotten whether it's double or single. 3 lenses. 3 convex lenses are used. And the 3 are objective, eyepiece. I've told that this one is erecting lens, the 3rd lens. Erecting lens. Then final image, VEM. Final image is visual, erect, and magnified. This one is visual, erect, and further inverted. We're not totally interested in Galilean, but we still write it. Galilean telescope. 2 lenses. Converging and diverging. And diverging. Final image. Visual, erect, and diminished. Galilean. Class, can you compare human eye with camera? What serves the same function as a diaphragm of a camera? Iris. What performs the same function as a ciliary muscle in camera? Diaphragm. What perform the same function as the retina of the human eye in camera? Which of them, the human eye or the camera, which of them has a fixed focus? Camera. The human eye, you can adjust the focal length of the human eye by the ciliary muscle you have. But once your ciliary muscle is affected, then you have lost your accommodation, not sight. You have lost accommodation. Then you now say you are presbyopic. Presbyopia. Presbyopia is a disease, then you have become presbyopic. And you need, what type of lenses do you need? Bifocal lens. Abi? For a normal sight, where is your far point? Hey, for a normal sight. Normal sight. If your eye is normal, you're not using glasses, then your far point should be infinity. Abi? Far point, infinity. What of your near point? 25. If you cannot see something very far, what are you suffering from? Short-sightedness. Cause of short-sightedness is a long eyeball. Would you your ball? If your eyeball is like the one of Arinze, then you may have the potential to be short-sighted. Long eyeball. Final image is before the retina. Before the retina. That's the way I recognize my own. That word short, that means it's shorter. That's how I got to know that before. Then we have correction, stepping dance. Larry comes. We are short-sighted. You need a diverging lens to correct that. Stepping dance. Larry comes. Then long-sightedness. When you have tiny eyeball or Georgia. Short eyeball. Final image is behind the retina. Behind the retina. And then we have correction. Larry comes. You need, for long-sightedness, you need converging lens. Like what causes astigmatism? Unequal focal length. Ciliary muscle. Presbyopia. Loss of accommodation. Cornea is affected. Very good. Wrinkling. Weakening of ciliary muscle. Ciliary muscle. Muscle. You need bifocal lens. Bifocal lens for correction. Astigmatism. The cornea is affected. Then you started seeing the land coming up. So start taking your leg. Then this one, you need a cylindrical lens. What vitamin can be used to correct some of these eye problems? Vitamin A. What are the fruits rich in vitamin A? Carrots, palm oil. Very good. When last did you eat carrot now? Last year? Last 2 years? Okay, carrot inside fried rice. My goodness, carrot inside fried rice. That one is no longer carrot. Oh. Now that they have boiled that, they remove all the fiber content of the carrots. The one you eat raw is the one that is good. So I've said it today that we may likely have our mock on Saturday. And we are still going to have classes. So don't think, because we don't have time anymore, and I don't want to cancel the mock. Because a promise, I promise you, you will do it, and many people are expecting it. Especially the serious ones. Even if the mock is tomorrow, you still pass it. Amen. I'm very sure any exam you write now, you pass. Because you have so many stuff on your head now. And some of you are still having fear. It's normal. It's normal, so, but don't allow it to dominate you. So we are through with that topic. We'll take some examples before the English class. Now for a telescope, distance between lenses is what? F0 plus FE. Maybe I should write down magnifying power of lens. All over F. F in meter. Then angular magnification for telescope. Which one? Final images before the retina. Short. Steven Dance. Short is for diverging. Astigmatism, cornea affected. Cylindrical lenses are required. Angular magnification of telescope. Telescope. FO over FE. Magnification of compound microscope. Magnification of compound microscope. Compound microscope. MOMI. Magnification of the objective times the one for the eyepiece. Are you true? You don't understand. You guys are talking there. Oh. Right, question 1. An astronomical telescope has objective and eyepiece lenses. 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 Of focal length 3.5 centimeter. Of focal length 3.5 centimeter. 3.5 centimeter and 5 centimeter respectively. 3.5 centimeter and 5 centimeter respectively. 5 centimeter respectively. Full stop. Determine the magnifying power of the telescope. Determine the magnifying power of the telescope when in normal adjustment. Magnifying power of the telescope when in normal adjustment. When in normal adjustment. When in normal adjustment. I'll give you the formula already. See it there. F naught over what? Fe. Focal length of the objective over what now? Focal length of the eyepiece. Let's solve it. Magnifying power of the telescope. F naught over Fe. Class, what's the answer? Magnifying power, MP. F naught over Fe. What's the focal length of the objective? 3.5. What of the focal length of the eyepiece? So what's the answer? This is a very useless telescope. Why is it useless? The one for the objective should have been higher than the one. That's why it doesn't have angular magnification greater than 1. You know, for a good telescope, the objective focal length should be higher or longer than the eyepiece. That's what they gave us, so we cannot question their question. Number 2. Give us diagram, sketch sheet. Draw. O. I for image. What are the following types of lenses? What are the following type of lenses? What are the following types of lenses? Is suitable for correcting. Is suitable for correcting the eye defects. For correcting the eye defect illustrated. Illustrated by the ray diagram above. Last work. Option A, by converging. By converging. Option B, by diverging. By diverging. By diverging. Option C, planodiverging. 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 Option D, diverging meniscus. Are you true? What type of lens what type of defect is this one? Short call. What is something longer than this retina? Longer. I'll show you. You know what I give you now. Before the retina is short-sightedness. Before short, longer than the retina. Long. That's how to remember it. So I don't want you to cram. It's longer than retina. Long-sightedness. And when you are long-sighted, what do you need to use? Converging lens. So that's by. So what's the meaning of by converging? That means both sides are converging. This is converging. These are under converging. This is by convex lens. What we call by converging lens. You can have one side plane, another one converging. This is plano-convex. Plano-convex. Only one side, but this is by converging. By convex lens. Okay, next question. No time again. Just waiting for Shirami to come in. Right, in a projection lantern, in a projection lantern, of focal length F, of focal length F, comma, the object distance U is such that the object distance U is such that, write the option. Option A, U greater than 2F. Option B, U less than F, less than 2F. Option C, U equals F, less than 2F. Option D, F is less than U, less than 12. As you know, the meaning of projection lantern. Have you heard the word projector before? And that's the meaning, projector. You know, if you have, you want to produce a seminar now, you can use a projector. You know, you put something like a slide, you get so many slides, and then start showing on the screen. Okay, let me just give you something like that. Quickly write. The projection lantern is operated in such a way, the projection lantern is operated in such a way, that a slide is placed between the projector lens. A slide is placed between the projection lens. A slide is placed between the projection lens. Projector lens outside the focal length. Outside its focal length. But before the center of curvature. Outside the focal length, but before the center of curvature. And is illuminated by a small but powerful light. From concave reflector. Small but powerful light from concave reflector. Full stop. The final image is real, inverted, and magnified. The final image is real, inverted and magnified. Real, inverted and magnified. Class, when will the image be real, inverted and magnified? Rim, when will it be real, inverted and magnified? Between C and F. So you can see that this one, between F, this is C, 2F is C. So when it's between focal length and the center of curvature. So the answer is D. Yeah. I've seen a projector before. There will be small light that will be, help to magnify the stuff on the screen so everybody can see. They even use projection now to watch football. They project the DSTV using a projector on a very big screen for the world to watch. Right, next one. Number what? Which are the following relations about the focal length? Which are the following relations about the focal length? Which are the following relations about the focal length? F naught of the objective. F naught of the objective. And focal length FE of the eyepiece. Focal length F naught of the objective. And focal length FE of the eyepiece of a compound microscope. Of a compound microscope is correct. I love this question. Which are the following relations about the focal length F naught of the objective lens and focal length FE of the eyepiece of a compound microscope is correct? Option A, F naught equals FE. F naught equals FE. Option B, F naught less than FE. Option C, F naught greater than FE. Option D, FE equals 2F naught. Okay. Do you know the answer? Is it microscope they are referring to? I gave you Moselle. Do you remember Moselle? So what is Moselle? Don't go and write Moses. So if you write Moses, you'll be wrong. Both of them should be short. Abi now. They are not equal. They must both be short, but they are not equal. Objective is shorter than what? Objective is short. Eyepiece is a bit long. Or you can use the word comparative now, longer. Is my grammar clear to all of you? They are both short, but one is longer. If I put two young girls that are short now, one is go still, top past the other one. So if objective is short, eyepiece is long, what's the answer now? BIB, objective shorter than eyepiece. Actually, welcome, sir. Sorry for stressing you on public holiday.